In this video, we'll be going over the complex numbers. And before we start talking about complex numbers, let's talk about the different number systems that we encounter in this class. So here are a list of all the different types of numbers that we'll encounter in this class. So let's just go through the list. First we have the natural numbers. And the natural numbers, sometimes these are called the counting numbers, because if we're going to count, we would start at 1. If we're going to count, a pile of apples, we would start at 1 and then proceed 2, 3, 4, 5, etc. So sometimes these are called the counting numbers. Next we have the whole numbers, and the whole numbers are just the counting numbers, but we include 0. So the whole numbers are just one extra number as compared to the natural numbers. The integers are the whole numbers, but they include the negative whole numbers as well. So any negative or positive whole number is an integer. Rational numbers, if we think about what the root word of rational, we have the word ratio. And a ratio is just a fraction. So a rational number is any number that we can write as a fraction. So specifically, any number in the form a over b, where a and b are integers, and b cannot equal 0. So any number that we can write as a fraction where the numerator and the denominator are integers and the denominator is not 0. So some examples of rational numbers would be 1/2, -3/10, 0 over 5, 4 over 1. Okay? So 4 is a rational number because we can write that as a fraction, 4 over 1. So an irrational number is a number that cannot be written in the form a over b. Okay, so an example of an irrational number, well, pi is an irrational number because we can't write that as a fraction. We can get close. 22 over 7 is pretty close, but it's not precise. Square root of 2, square root of 3, square root of 5. There's a lot of square roots. Okay. Next we have a real number. All of these make up the different categories of real numbers. This isn't a very precise definition, but a real number is any number that can be found on the number line. So going through, the natural numbers are going to be on the number line, 1, 2, 3, 4, etc. Whole numbers, we have 0. The integers, well, that's just going to be the negatives. The rational numbers, so 1/2 might be right here. Pi, well, pi is a little bit more than 3. Okay, square root of 2 is between 1 and 2. Okay, so all these numbers we can say have an address on the number line. Now, complex numbers do not have an address on the number line. So complex numbers are a little bit different than everything else we've talked about here. So what is a complex number? To talk about a complex number, we first need to talk about the imaginary number I. And I is defined as the square root of -1. So when we take the square root of a -1, that is equal to the imaginary number I. And if we square both sides of that equation, we would say I squared is equal to -1. So a complex number uses the imaginary number I, and we could say that a complex number is the sum of a real number and an imaginary number. We write this in the form a plus bi, where a is a real number. Actually, a and b are both real numbers. Let me fix that. Okay, so a and b are real numbers. So an example of an imaginary number might be something like 5 plus 3i, negative 4 minus 2i, 3 plus square root 2i. Okay, so each a and b value are real numbers, and then we have an I. So what we say is this first part, we'd say, is the real part of the complex number, and this part we would say is the imaginary part of the complex number. Next, let's talk about how we can perform different operations on complex numbers. So adding and subtracting, very straightforward. So if I have something like 3 plus 2i, and I want to add that to 5 minus 6i, we just combine the like terms. So it's kind of like the I terms go together and the constant terms go together. So when I add this, we're just going to get 9 minus 4i. Okay. If we're going to subtract complex numbers, let's do 1 minus I minus 6 minus 3i. We can distribute that negative through. Combine the like terms, we get negative 5 plus 2i. Right, so that should be pretty straightforward. If we're going to multiply complex numbers, I'll just multiply the same two from this example. How we do this is it's just like we're multiplying two binomials. So 3 times 5 is 15, 3 times negative 6i is negative 18i, 2i plus 5 is 10i, and then minus 12i squared. So one thing we need to keep in mind, well, first we can combine the like terms, so negative 8i, and then we need to remember that I squared is equal to negative 1. So in that last term I have negative 12 times negative 1, which is positive 12. Combine the 15 and the 12, you end up with 17 minus 8i. Okay, so the thing to keep in mind when we're multiplying complex numbers is that I squared that we'll often end up with. And then dividing complex numbers, let's look at a new slide here. So if we have something like this, two complex numbers getting divided, well, we know that we can write a division problem as a fraction. Now, a common thing we'll want to do is write this fraction. Well, the issue with this form is that this is not an a plus bi form. Okay, so what we need to do is multiply by the conjugate. So we just take the denominator and write it with the opposite operation. So if it's plus, we make it minus. If it's minus, we make it plus. And then we just multiply the numerators together, multiply the denominators together. So upstairs we end up with 24 plus 6i plus 12i plus 3i squared. In the denominator we get 16 plus 4i minus 4i minus I squared. Okay, so in the denominator the 4i and the negative 4i cancel. This I squared is negative 1. In the numerator we also have an I squared, so this is also negative 1. So in the numerator we can combine the 6i and the 12i to 18i, and then 24, this is 3 times negative 1, so negative 3, 24 minus 3 is 21. So 21 plus 18i divided by, I have 16 minus negative 1, so 17. Alright, now if we look at this, it doesn't really look like it's in a plus bi form, but we can write each of these, we can split this up into two fractions, and now this is in a plus bi form. Remember, a and b just need to be real numbers, not necessarily integers. So, performing operations on complex numbers, it works pretty much exactly how we would expect any algebraic operation to work. We just need to be aware of any time we end up with an I squared here. So next, let's see what is a practical use of a complex number. Well, we need complex numbers often when we are solving equations. Okay, so when I take the square root of both sides here, square root of x squared is x. So when I take the square root of negative 4, I can rewrite that as 4 times negative 1. And we know that negative 1 is equal to I. So x is equal to I times the square root of 4. Square root of 4 is 2, or plus or minus 2. So we're going to say x is equal to plus or minus 2I here. We could also see this in a 3-term quadratic equation. X squared plus 2x plus 2 is equal to 0. Now, when we have 3 terms like this, if the trinomial does not factor, we need to use the quadratic formula. So there's another video that'll go into the quadratic formula a little bit more in depth. But I'll do this quickly. So 2 squared plus 4, it's actually minus 4ac all over 2 times 1. So we end up with negative 2 plus or minus. Simplifying under the radical, we get 4 minus 8, so negative 4 divided by 2. Now we already saw what happens when we have negative 4. Square root of negative 4, that's 2i divided by 2. So we'll factor out a 2 here from the top and bottom. We'll end up with negative 1 plus or minus I as our solution. And again, we'll see the quadratic formula a little more in depth in a different video. Alright, lastly we want to see how we can simplify different powers of I. So if I have I to the first, I to the second, I to the third, I to the fourth, and so on. How do we simplify these? Okay, so I to the first, well that's just I. I squared we already saw is negative 1. Okay, I cubed, well we can write that as I squared times I to the first, which are just these two, so negative 1 times I, so negative I. So what we get when we have I cubed. I to the fourth, well that we can write as I squared times I squared, which is going to be negative 1 times negative 1, which is 1. Okay, so let's remember this pattern. I, negative 1, negative I, 1. Okay, when we have I to the fifth, well we can rewrite that as I to the fourth times I, or I to the first I should say. I to the fourth we already saw, well that's equal to 1. I to the first is I, so this is just equal to I. I to the sixth, we could write this as I to the fourth times I squared. Well, we already saw I to the fourth is 1. I squared is negative 1. So this is just negative 1. Yeah, sorry, got a little tripped up there. Yep, negative 1. Alright, I to the seventh, well we could write that as I to the fourth times I cubed. I to the fourth is 1. I cubed is negative I. So this is negative I, and then I to the eighth we can write as I to the fourth times I to the fourth, which is 1 times 1, which is 1. Alright, so all of this to say, we end up with the exact same pattern. So, what's happening is every time we get to a multiple of 4, this pattern repeats itself. So I, negative 1, negative I, 1. So because it repeats itself every 4, we can use this fact to simplify something like this. I to the 35th. Well, if we take 35 and we divide 35 and divide by 4. Well, 4 goes into 35 8 times, and we have a remainder of 3. So the remainder is what we really care about. Now, if the remainder is 3, we're going to end up in this situation where I to the 35th is equal to negative I. Okay? If you don't believe me, well, we could just rewrite I to the 35th as I to the 4th times I to the 4th. We do that 8 times. Okay, to get us I to the 32nd, and then we have I to the 3rd left over. And we know that I to the 4th is 1, so we'd have 1 times 1 times 1, 8 times. And then I to the 3rd is equal to negative 1. So the moral of the story here is if we have I to some exponent, just divide that exponent by 4. So in this case, 18 divided by 4, it goes in 4 times. The remainder is 2, and the remainder is what we really care about. So because the remainder is 2, we're going to be right here, which is negative 1. And that's it. So that's how we simplify powers of I.